Hi, folks. Hope you're doing well. Sorry to miss your class here. Well, we're going over the review today, so hopefully the sub gave you the review. I mean, you can try some of them on your own, or you can follow along with me, but I do think there's some useful things to gather from this video. And the main one is we're going to go over a little bit of your homework here. Okay, so we're going to go over the homework a little bit. I just picked out 31. Figure you all want to do the proof. If you have other questions about the homework, feel free to email me or come in before school or anything. Again, if you aren't given a picture for your proof, you should draw it. So that's where you should start. My segment isn't super straight there, but you get the point. We got JK. L is the midpoint. So right away on your picture, go away, the stupid little, there it goes. Right away on your picture, we know these segments are congruent because that's a midpoint. So mark that so you can see that. Okay. And then this next part, you can kind of draw in multiple different ways. They're all going to kind of look the same. But we know JK intersects MK. So there's another segment here. All right. And this is M. Okay. So there's your picture. And then we're going to go ahead and we're going to make our two columns. Wow, that was a straight line. That's what we're talking about. S stands for statement, R stands for reasons. We're going to write in our given. So we got point L is the midpoint. Sorry about the handwriting on the Zoom is not great. So let's see. Now, technically, the second sentence is a given right here. This black one I underlined, that is a given statement. It really just helped us draw the picture. So I don't think you need to necessarily put that in the given, but this is also part of the given. If you ever see anything that's like if, that means they're saying this is true for this proof. Okay, so we're going to put in MK is congruent to JL. And then that's our given. That looked really bad on the Zoom, but that's okay. I do it better in person. You'll see it sometime. Cool. So that's just your givens. Okay. Now we're going to take this first given and we're going to use it. Okay. L is the midpoint of JK. What does that tell us? Tells us JL is congruent to KL or LK, however you want to say it. Which one have we been doing? We'll say LK. So we're going to say JL is congruent to LK. And what's the reason there, folks? What's the reason? Yeah, Nash, what do you think? Yeah, midpoint theorem. Okay. Now, some people on their homework, I saw this, some people on their homework did definition of a midpoint because they felt more comfortable with that, and then definition of congruent segments. That's great. That works too. You can do that. But you need to get congruency. Do you see how this one's incongruent? And what we're trying to prove here is incongruent. So we need everything to be congruent. So you could do that with midpoint theorem. You could also do that with definition of midpoint and then definition of congruent segments. But we need both, okay, to be congruent. All right. Now look at what's happening here, okay? Look at what's happening. We have JL here and here. Both of these things are equal to JL. Okay, there's a property called the transitive property that says if A equals B and B equals C, then A equals C. Okay, it's called the transitive property. That makes sense, right? Two things equal the same thing, then they have to equal each other. All right, and we see this come up a good amount, but here it is. You can see they're both congruent to JL, so they got to be congruent to each other. And so we can say LK is congruent to MK. And I know some of you asked what this was called in class, and I was like, well, I'll just tell you. And I kind of forgot I wasn't going to see you. But this is called the transitive property. Okay, this is called the transitive property. If two things are equal to another thing, then they're equal to each other. Okay, so transitive property. That should be your proof. Look at the proof statement. We got to the proof statement, so that's it. You can do whatever little mark you want to end your proof there. And there you go. That's the proof. So if you have other homework questions, send me an email, come to my room some other day, some other time, and we'll do it. So what's happening here? So this is what we started chapter 2 with. We were looking at sequences and patterns, and we were doing inductive reasoning. Uh, and there's a couple different ways you can think of this. I think the easiest way, though, is that they're just adding three blocks to the bottom each time, right? So you could draw the next one in the pattern. Mine's going to look really bad, but you get the gist of just adding another block there. Did I do one too many, I feel like? Did one too many. You get it. Draw the next one in the pattern, and then we'd say something like, maybe I'll just type it. We add three blocks to the bottom of the previous figure. Okay? That'd be your answer. All right. I think there's one further down here. Okay, so then you got this one. This is a classic problem. Okay, super classic. So one, sometimes people look at this. Okay, so we're adding three, we're adding five, we're adding seven. Okay, so we add two more than we did the previous. That's one way you could give a conjecture. That would be correct. And then your next one would be, let's see, 9. So you'd add 11. So it'd be 36. So that would work. Another one you can do is that these are all squares of whole numbers. So you get 1 squared, you got 2 squared, you got 3 squared, you got 4 squared, et cetera, all the way to 6 squared, which also gives you 36. Okay, either of those work. There might be other ways to think about this problem, but that is kind of the sequence we're seeing out there. Alrighty, we're moving along. Now I put three different truth tables on here. Um, feel free to practice on these two, and then if you want, you could just practice those on your own. But of course, the one on the quiz is going to be a three-statement truth table. Let's go ahead and we'll make our so straight for so long and then it failed. Go ahead and make our columns here. And we got P and Q and R. Okay. So again, for the three statement one, we're going to go four truths. And again, these first three things you always can set up the same. We're going to go four truths and four falses. For Q, good old Q ski, we're going to go two truths, two falses. This one was a false. Oh, God, that looks terrible. I used to be pretty good at this when we were in COVID and I could write pretty well. And then R, we're going to alternate every time. True, false, true, false, true, false. One more. We got it. Good work, everybody. Okay, so next, we don't have anything that's negated in this one. That's nice. So we don't need to do negation of Q, P, or R because there's no negation in here. So we're going to jump right into Q and R, okay, which is a conjunction between Q and R. Oh my heavens, that is a terrible line. And then our last one is going to be the whole thing, okay? But again, we're doing this piecemeal so that we can just only have to look at two columns and not overuse our brains. Okay, so we're looking at Q and R here is going to make this, and it's a conjunction. Okay, so we are true only when there's two trues. Again, you could go through line by line and um, pick out each one, or you could look, the conjunction is only true when two trues are true. We got one there, and we got one here, and that's it. Everywhere else is false, 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 false. So we can just kind of go false. Sorry, starting with the true. The first one's true. And then we're going to go false, and then false, and then false. Because we have at least one false in all those. Here's another two trues. And then we got a false. And we got a false. And we got a false. Okay? So that's the conjunction. And then we're going to take our conjunction we just did, change colors one more time. And we're going to, for our last column, we're going to be looking at our previous one, plus now we're going to bring in the P, statement P. And now since it is a disjunction, we only need one true. So again, you could go through each one and we see true, true is going to give us true. So you could go through like that, or the only time it's going to be false is when we have two falses. So here's a false. Here's a, wow, this is a cool one. It's the last three. So these are where we have our double falses. It's the last three. Everywhere else we have at least one true. You see that? So we're going to go five trues. Funny that I say I don't know if I've ever seen that, and I probably did this problem 3 times last year for 3 different classes. But I don't remember it being this nice. Look at that. 5 trues, 3 falses. And there's your beautiful truth table. It's a thing of beauty. Okay, so there's that. We're just kind of cruising along here. We're into the good stuff. I'm gonna maybe go into some more typing here just because it's easier than me trying to write it out, and then you don't have to struggle watching me write. Hypothesis and conclusion of a conditional, and then be able to write the converse, inverse, and contrapositive. And this is without truth value. There's two here. You could practice on either of them. Let's do B because it sticks with a little bit more mathy thing. Remember, the hypothesis is just the statement with the if. You don't need to include the if. So it'd be two angles are vertical angles. That would be the hypothesis. And then the conclusion, they are congruent. Now, another thing to remember, we already have the original conditional, so let's just rewrite that. Two angles are vertical angles, then they are congruent is the original conditional. Now remember, we want to keep the subject at the start of our conditional. So even when we do the converse, we don't completely flip it. We don't say when they are congruent or if they are congruent. We don't know what they are. They are the two angles. So we can say if two angles are congruent, then they are vertical angles. So we kept our subject at the start. Okay, we kept our subject at the start there. And then the inverse, we just take our original conditional. We're just going to negate both. So to keep the original conditional, but now we say two angles are not vertical angles. then they are not congruent. Okay, so we just took the negation of both of them. And then lastly, everybody's favorite, we negate and flip. So if two angles are congruent, then they are vertical. Right? Pretty straightforward. I feel like we have this down pretty well. I think we have it down pretty well. I think we got another example here. So this one we're going to go through. We're going to do the conditional, the converse, the inverse, and the contrapositive, but we are going to say if they are true or false. Let's do A. So the original conditional, let's just rewrite it. If a number is divisible by 4, then it is divisible by 2. And then we have our truth value, which in this case would be true, right? Anything divisible by 4 should also be divisible by 2. I'm thinking of 16, 20, 100. That should work out. Now our converse, flip the hypothesis and the conclusion. We keep the same subject. If a number is divisible by 2, then it is divisible by 4. What do you think the truth value is this time? Sounds pretty quiet out there. Who do we got? Leo in the back. Let's go, dude. Uh, false? Yeah. Can you give me a counterexample? 6? Yeah, that's a good counterexample. And we're talking about like evenly divisible, right? We're not like, oh, well, that's a fraction. No, just evenly divisible. 6 is divisible by 2, but not by 4, so that's false. Let's do the inverse. If a number is not divisible by 4, then it is not divisible by 2. And just like the one we just did, that would also be false. And let's give another example. 18 is divisible by 2, but not by 4. Remember, our converse and our inverse go together, and then our conditional and our contrapositive go together. So the final one, if a number is not divisible by 2, then it is not divisible by 4. And that is true. Okay? So again, you have something like that on the quiz. Be ready to write it all out. Give a truth value. Remember that the conditional and the contrapositive go together, and the converse and the inverse go together. Ooh, we got a proof. What else we got? A little sometimes, always, never. Okay, and then we got some fun ones. All right, let's do another proof. Now, there's a couple of proofs in your book. You can practice a bunch of those. It is hard to find proofs because we're in such a narrow proof range right now. But let's go ahead. We'll give another proof shot. Again, you don't have a picture. Draw it. Draw the picture. So we got XZ segment. And Y is exactly in the middle. It's the midpoint. Again, you could just give your little slashes there. And then Z is the midpoint of YW. Again, you got like an offshoot. Whoa, Z is the midpoint of YW. So maybe it doesn't look like that. Let's give that one more try. I think we should keep it flat. I didn't read that carefully enough. So we got YW and then Z is the midpoint of that. Okay, so this gets split evenly. Whoa, hello. So we got two midpoints, and then we got to prove that XY is congruent to ZY. All right, let's make our table here. Two column proof as always. Oh, that's a straight line. Why can I do it so well sideways and not up down? Statements on the left, reasons on the right. Let's type a little bit. Oh boy, sorry. It's just hard to type out those givens. Let's make small font a little smaller. Okay. Point Y is midpoint of XE. Z is midpoint of YW. And those were both givens. Okay. So again, look at what we're proving here. And we are proving a congruent. Okay. So we want everything in congruency. Again, you could use definition of midpoint and then definition of congruent segments, but it's just more efficient to just use midpoint theorem. So y is the midpoint of xz, so we can say xy is congruent to yz. And that's just midpoint theorem, baby. All day long. Okay. And then let's repeat with this one here. We know YZ and ZW are congruent because Z is the midpoint, right? You could say YZ. Again, use your givens. This is all just given to you that those are the midpoints. And then you just say midpoint formula, midpoint theorem, and then you're good to go. So again, midpoint theorem, you can rewrite it, or I haven't shown you this yet, but if you just do like a little quote, that just means same as above. So you don't have to rewrite it 10 times. And then look, we got YZ here. XY is congruent to YZ, and guess what? So is ZW. So you're going to see your favorite new property once again. We're going to say XY is congruent to ZW. By the transitive property. Oh my gosh, that I got out of control. That was a heck of an R. Okay, transitive prop, the old transitive property. And then you got to end your proof because that was what we're trying to prove, right? XY is congruent to ZW, and we did. And then we go big old QED. Another proof down. Okay? Nothing too crazy there, kids. Determine whether the statement is always, sometimes, or never true. If points M, N, and P lie in plane X and they are collinear. Interesting. Interesting. Okay, so we got 3 points in a plane. They don't say how they lie in that plane. They don't say that there's only one plane that goes through them. If they said, hey, there's exactly one plane, plane X, that goes through the 3 points, then you know that they're non-collinear. So I'm going to say sometimes here because I think you could say, hey, these are on a line in plane X, and so they are collinear, and that there's other planes that go through them, or maybe they're spread out. We need more info there. So I think sometimes is a good answer. Intersection of two planes can be a point. That's never. Two planes intersect to form a line. Now, if it was 3 planes or 4 planes, then we could say yes. But if it's just two, they gotta form a good old line. Okay, so here we got some conditional statements. We're going to say if it's true or false. If it's false, we're going to give a counterexample. If two angles are acute, then they are supplementary. Supplementary angles have to add up to how much? How much? 180 out there. So they have to add up to 180. Two angles are acute, so they're both less than 90. So I'm gonna have to say false because that's not gonna happen. Okay, and a great counterexample here. This is a fun one. The biggest acute angles you can get is 89.999, but we're just going to say 89. And 89 plus 89 is what? 178. So it is not supplementary. You cannot have supplementary if they're both acute. Okay? If a number is odd, it is divisible by 5. Also going to say false to that one. There are some odd numbers that are divisible by 5, but not all of them. And let's say 21. Good number. It's odd, but does not divisible by 5. Lastly, if a banana is blue, then an apple is a vegetable. Kind of a fun one. There might be blue bananas somewhere. I've never seen one. So we're going to say true by default because the hypothesis is false. I haven't seen a blue banana. If you find one, send me a picture. And so it doesn't matter what the conclusion is because that first hypothesis is false. I think that was the review. So hopefully you went through that, you watched this video, you followed along, you did some problems with me, and you feel good about it. And if you have any questions, feel free to send me an email. Stop by anytime, Friday, Monday, maybe even stop by Thursday before this class, but Friday or Monday before school or second lunch is always best for me, but try to come by anytime. I hope you have a great rest of your day. I'm over at Metros watching the cross country championships. We'll see you later. We'll see you soon.